Everyone's. So, good evening again. I hope you're having a good week. Today we'll be speaking on infrastructure as a code and how to secure this particular area. And with us is Kiiru Maina, who is a product security architect from Equity Bank. He's also an alumna of the Cyber Shuja program, and we look forward to listening to his insights. So, karibu sana Kiiru. Welcome to another Cyber Shuja session.
Hello, hi, good afternoon. Hope and 40 other participants in the meeting. Thank you. I hope you have a lovely morning, afternoon, or evening, wherever you are. Just like Hope said, my name is Kiiru Maina. Today's session is going to be. I intend to do today's session about. I intend to talk about infrastructure as code, IaC, or specifically IaC, IaC security. So yeah, I might use infrastructure as code or IaC, but mostly when I say IaC, I'm referring to infrastructure as code because infrastructure as code is a mouthful. So yeah, with that being said, allow me to share my screen. So, okay, good. Screen. Can share tabs nowadays. Okay, cool. So kindly, you can tell me if this is on presentation mode.
Yes, it is.
Okay, perfect. So I think we can start. Hello? Hello? We together? Someone wave something.
Yes,
Okay.
yeah.
Okay. So this session, we shall just talk about what infrastructure as code is, and then why security as code matters in IaC matters, and common security risks in IaC, best practices, and then do a demo so that you guys are able to for better understanding and more tangibility to avoid a lot of theory. And then you'll have a Q&A, and then we can call it a night, afternoon, evening, or a morning. Okay, so actually a night or a day. So yeah, with that being said, I will proceed to the next slide. So what is infrastructure as code? So this, according to the internet, IaC is a practice of managing and provisioning computing infrastructure through machine-readable configuration files rather than manual processes. According to me, it's just like a magic wand that you can wave and tell your infrastructure what to do. So yeah, without necessarily having to manually do it. So how is this done? So when you're an example, if you're setting up you're setting up we're setting up cloud environment. Will you need to, let's say if you want to provision a server, for example, a virtual machine, you have to go and manually go press a button, tell it do this. I want this type of machine with this particular specs, with this particular other configurations, and then you press OK, and then it deploys, and then you use it. So what IaC does is it gets rid of that process. Now you just define what you want programmatically, and then it it connects with whatever resource it is that you want to connect with. And then once that is done, it provisions, or it deletes, it updates, it does whatever it is you want to do with that particular piece of resource that you're using. Could be on the cloud, could be on premise, could be a SaaS, so on and so forth. The possibilities are virtually endless. So yeah, so the benefits of this as compared to manually doing it is you have some form of consistency. So if you have a standard or a set of policies, then you're able to consistently you're able to deploy, you're able to provision infrastructure in one uniform manner through one system, and also as documentation, you're able to properly document whatever it is that you're doing. So at the end of the day, the truth teller in this particular in your infrastructure is going to be uh, a, a, a repository somewhere with code that defines how exactly every piece of infrastructure sits within your cloud or on-premise state. And then version control, basically able to say last year we had things deployed like this, now this year we don't have this, or we improved on this, and so on and so forth. Just basically the benefits of version control in code is the same thing you put on IaC. And then automation, I think I explained automation by the fact that it works like a magic wand. And then scalability. So with scalability, you're able to easily um, manage multiple pieces of infrastructure. Could be on your cloud, on-prem. Most IaC tools will give you the ability to manage scenarios where you have like a multi-cloud setup going on for you. So yes, so I think I've talked about the benefits. So some of these popular tools are HashiCorp Terraform has taken that cup. You have another one called Pulumi. So Pulumi is an IC tool that allows you to now write code. Terraform allows you to do something that's very readable. It's close to it's a very high level configuration language. I think I'll display that. Pulumi is very programmatic, so you can use your JavaScript, your Python, and so on and so forth. Then you have Ansible. So yes, and then you have others that are biased to cloud service providers. I think AWS has their own, uh, Azure has their own. So yeah, there are some IaC tools that are a bit CSP centric. So yeah, so why does security matter? So like I said, this thing is in charge of IaC is basically in charge of taking care of of managing your cloud, your infrastructure generally. So the fact that you define it, if you make a misconfiguration on your code, then this boils down to an infrastructure level vulnerability. So this will lead to things like missteps, uh, some of these issues, if not well taken care of, can lead to data leaks, unauthorized access, service downtime, and so on and so forth. They're basically a reputational risk. So the risks are not just limited to tech, but also to business. So service downtime, loss of funds, reputational risks, compliance issues, and so on and so forth. And then so with IaC, you're able to see security. You have the ability to see security issues even before you deploy your application, your infrastructure. Sorry, I've been doing quite a bit of DevSecOps lately, so application comes a lot. Yeah, so deploy your infrastructure. So early detection of these particular issues. So when you're writing code, as I will show you, as you're defining your infrastructure, then you're able to see these things depending on how exactly your setup is, you're able to see this as early as development. So yeah, I think that way you're able to avert potential breaches way before you deploy. So I think I cannot stress on why security in IaC matters. Is there a question? You can hear someone wanting to say something. Anybody? Okay. I assume that was someone who had not muted their mic. So can proceed. So the common risks will be hard-coded secrets. This will be API keys, passwords, and so on and so forth, especially when you're authenticating to different providers. So this will be, let's say, your DNS provider, your cloud service providers, your Active Directory, and so on and so forth. So people tend to, you might be tempted to hard code these secrets because it's easy to do it. And once you hard code these secrets and they go to version control, and unfortunately, one time, an intern opens, oh, well, I'm sending out love to all interns. This is just an example. Yeah, when they open, unfortunately, this repository is made public, then your API keys is out there for the attacker to use and consume. Yeah, and then the other misconfigured access control. So because this IaC is, your code is basically managing everything. So the accounts used to manage I manage your infrastructure is could have admin permissions or super user permissions, meaning that if a malicious actor gets access to this particular account, they can be able to do virtually anything on your infrastructure. And then insecure defaults, running open ports and encrypted storage when you're deploying infrastructure. And finally, drifts and untracked changes. So once in a while, people tend to bypass if you have a set rule, if we draw a line and we say nobody uses, nobody manually deploys infrastructure on the cloud, but then we're going to use our IaC, we're going to use our IaC tool that we have, then somebody goes ahead and decides, you know what, we're going to manually deploy this. So that way you lack visibility and you can't, if you, in some cases, depending on the IaC tool that you're using, uh, when you can't manually go write it on code again because you're going to have issues. It's going to tell you that this thing already exists and it's not going to be added it's not going to be properly onboarded by your IaC tool because the IaC tool has, depending on whatever IaC tool you're using, I think I'm a bit biased. So the state will not be updated properly. So you'll have untracked changes and you'll have a drift based on what you have on IaC and what you have on the ground. So yeah, and then finally, dependency vulnerabilities. So using insecure modules, unofficial modules, and plugins from third-party vendors. So someone has created their own module for maybe interacting with AWS and you're not using the official AWS module. So then you expose yourself to vulnerabilities based on that AWS AWS China, oh sorry, AWS 123 module that is not tracked by anybody. Yes, that is not maintained by a community or by AWS themselves or so on and so forth. Yeah, so, uh, sorry, I forgot to change the topic, but basically, where I was going with this was where I was going with this particular topic, where I was going with this particular slide was the solutions you can use to manage to manage to manage the risks that I have earlier highlighted. So secrets management to prevent hard coding of keys and passwords and so on and so forth. And the credentials basically and the sensitive information. Version control. So this way, before you deploy infrastructure, you can have a setup where people are able to review what it is that you're doing and offer more sentiments and guidance, just another set of eyes to look at whatever it is that you're doing. And then the other one was static analysis and security scanning. So uh, having tools to detect misconfigurations. So you can have these tools on your IDE or on your on your on your deployment pipeline, and then list privilege principles to prevent giving more than enough permissions to the account that is responsible for authenticating your IaC solution to whatever piece of infrastructure that you're using. And then immutable infrastructure. So basically, uh, just avoid code to avoid manually putting stuff on the cloud. So that way, you're able to prevent cases where people are drifting from whatever it is you have agreed on. And then finally, automated compliance checks. So I will talk about this particular point on on a very high level. And if Hope gives me the chance, we will have a conversation about it in depth another time. So this can be done by uh, policy as code. So basically, for people who, for in organizations, you need to have the people responsible for defining this governance, these policies and procedures usually put it in Word. So it's very difficult, not necessarily on Word. It could be a Word or a wiki or so on and so forth. It becomes very difficult for you to track whether these policies that you have put here, if we say all databases need to be encrypted at rest on our data encryption policy, are you able to ensure that this database is encrypted uh, and is encrypted at rest? So compliance policy as code comes in to solve that particular problem, because now you're able to write those policies in a programmatic manner, and then you're able to test whether this policy is what is on this policy is what is whether the contents of this policy is what is being implemented. So that way you can have rules in place to check, okay, if our IEC does not conform to the policy, then it should not be deployed at all. If yeah, so I think that's an open. I think we'll talk about that another time, and yeah, but for now, let's stick to this. So basically, so that's basically it. So I wanted to ease through the slides very fast so that you can have a demonstration and then we can start. Yeah, so my IaC tool of choice in this demonstration is Terraform. In this particular demonstration, I am basically setting up.
Kiru,
Yes. Hope.
uh,
Yep.
just a minute. So before you go into that, there's a hand that has been up. Ahmed,
Oh.
maybe he has a
Oh.
question.
Okay.
Yeah.
Okay. Yes, Ahmed. How may I assist you today?
In the previous two slides,
Uh-huh.
are those security risks brought about by the use of infrastructure as code or the risk that infrastructure as code aim to mitigate?
It's brought about by use of infrastructure as code.
Okay.
Yeah, and then the next slide is how to mitigate them.
Okay, thank you.
We together. Yeah, we together.
Yeah.
Okay, perfect. So, like I said, my tool of choice is going to be my IaC solution of choice is going to be Terraform. My uh, cloud solution, my infrastructure, the piece of infrastructure that I'm managing is going to be on AWS. So I think that's I think that serves as an introduction. So it through uh, an introduction to Terraform very fast. So basically, do not get intimidated by this many things. In fact, let me close them. So, so for Terraform to interact with AWS, you need to use something known as a provider. So a provider is basically a library that has been authored by uh, a service provider. So this could be AWS, it could be Google Cloud, it could be Cloudflare, it could be uh, HashiCorp Vault, it could be GitHub, it could be so on and so forth. Think of anything, Windows, DigitalOcean, blah, 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 blah. Yeah, the list goes on and on and on and on. So basically, um, what you do is, so that's thing this that's the provider is what we call here, as you can see on my line 2 to line 8. So I specify my version and the source. So the source is, you see, this comes from an official partner. So this is the official library for AWS on for to be used on Terraform. And then you specify your version, and then you can skip all these things because they're not relevant here. So you can see I defined my network. I defined a security group, which is basically uh, firewall rules. And then so basically I have a rule to allow TLS. I have an I defined an internal subnet, and I defined a public subnet. These are for things that will be exposed to the internet, and then the other ones being exposed to just within my AWS environment. And then you have your internet gateway, and then you have your routing table that connects this your gateway to your network, and then you have your association, just that connects your routing table to your public subnet. And then now we are load balancing two instances. So I think this is where we should focus on. So mhm. So we have an EC2 instance that I am calling Web Server 1. So Web Server 1 is an Amazon Linux 2 instance, and then you have the instance type, whether it's a T2 micro, T3 micro, and so for me, I've taken a T3 micro, and then it's going to be on my internal subnet, and then it's optimized to this is 79 is too much information. So 80 is basically allowing monitoring, and then security group tells it what ports I want opened. So the load balancing security group basically opens ports 443. So basically that's the only port I want to open for this particular instance. And then I have another instance with basically the same configurations, so I shall not talk about it. And then I now have a load balancer that balances the traffic between between these two instances. So what I was doing is, what I'm simulating is a situation where I have on a website that people are accessing. And if I have so many people accessing this website at one given time, then traffic is going to spike and my resources are going to be exhausted. And then I will, my website is going to be down and my customers are not going to access my service. So to take care of that, I have two servers. I have two web servers. So these two web servers are going to be controlled by a load balancer. So basically what this load balancer is going to do is it's going to sit in front. Think of it as a washroom. So if I have uh, a gents washroom with two cubicles, so so I need to have a place where guys are going to come in and go to these cubicles. So this web load balancer acts as a, well, washroom is not the best example when you really think about it, but let's continue. The message has been driven home. So yeah, so you have so you have you have these two cubicles, which is web server 1 and web server 2. Then you have a main door, which acts as the load balancer. So basically, it's going to distribute traffic to these two, uh, to these two, to these two servers, so that a customer can be able to, regardless of the volume, our customers are able to get served. So yeah, so basically that's it. So we have uh, a load balancer, and you say it's going to be public facing. It's going to be an application load balancer. So I'm not going to delve into AWS specifics because I'm avoiding to go on a tangent. And then security groups, again, we only want 443 opened. This is going to be on the public subnet, and then you're going to have, uh, if we have, this is a security configuration where that is where I am going to. So if we want to, if someone sends invalid header fields, they should be dropped at the load balancer. So that's a security configuration. And then you have a target group, which is supposed to combine these two servers and make them one. So basically, these servers will be treated as one group, and then they connect to the load balancer. And then, yeah, so basically, that's it. So we have written all this, right? So once you have written all this, we're going to use a normal developer flow where you have a version control tool, version control solution. So in this case, I used GitHub because why not? And so allow me to bring my GitHub into the picture. So basically, this is the whole essence of version controlling. So you're able to see all the changes that have been made on my environment. So right now, as you can see, I have AWS and DigitalOcean. So if you go back in time, you'll be able to see many other things that I had uh, as far as 1 year, 1 year, 1.5, 2 years ago. So you're able to see everything that I've done. So there's a documentation on my cloud spend. So this is not going to be organization grid. This is a very hobbyist setup, but it solves the problem. So yeah, I think so. When I create this load balancer, because I have the branching, I use branches. I come and raise a pull request, and then so this is what I was going to demo with. As you can see, I have other problems at the bottom. So let's use the one that works. So so on my IDE, I have Sneak that does the checks for me. However, Sneak for some reason decided not to work today. So I'm not able to show that properly. So I will show you what I have on my pipeline as an extra step for verification. So now, what I have is, oh, you can see I have a comment here that says what exactly I've done, and then I have a tool called Checkov. So what Checkov does scans my code before deployment. So this is where the proactiveness comes in. So it comes and scans. Once it scans my code, I have a I have a I have set up this GitHub Actions bot to give me feedback as a comment. So this is where the security part comes in. So as you can see, I have what's it called? I am told ensure VPC subnets does not assign public IPs by default. So I'm told this is on my, so they tell me where this is. So this is on my public subnet. I will not obey that for now because of reasons best known to me. And then I have this one. So ensure all data stored in the launch configuration or instance EBS server is securely encrypted. So that is something we might look at. So if you want more information on this particular guideline, we can open this particular link, and then so it tells me this is on my web server one. So I come and check this particular place, and then I'm able to read and see Amazon ABS volumes allow you to basically what ABS does, and when the entire ABS volume is encrypted, data stored address, blah blah blah, and then how how exactly to do it. So let's say if I have a block device, I come, so I need to add this onto my AWS configuration. So I will come to my file here. Uh, we said this was on web server one, right? So I'll come and add it here and say, sorry, okay, what are we going to say? We're going to add this attribute root block device, and then that block, and then add that attribute. So root block device, and then encrypted is true, and then okay, and then we need to have volume size is, actually this is very important. I don't know why I forgot to put this. And then volume type should be GB3. So yeah, so now I have taken care of that particular issue. So if let's copy it on our other web server. So this is here. So yeah. So now you're able to actually you'll be able to see more on, let's hope the demo gods work. The demo gods are with me today. So encrypted block device. So okay. So it does just give it a moment. So it's going to basically push my code to this particular branch, which is now done. And then I will be able to come and see this. So so as you can see, there are two scans here. So I will go to I will tell you what is happening on the two of them. So basically, what is happening is it's checking for any misconfigurations, formatting for, because for people who like very neat code. So that way, it checks this for me. If it hasn't done it, I have to do it manually. So, and then it tells me what exactly is going to change. So as you can see, it tells me I am going to create a new server with this particular information. So it tells me your EC2 instance is going to be on US East 1. The ones that are written known after apply are things that I have not deployed yet, but it will go check. So where is it checking from? It's checking from this particular point. So what I have is a file that is stored on S3 that stores my Aziz. Oh, this is actually the best place to start. So basically what I have is a place written, a set of files that have my Aziz configuration. So this is an S3 bucket. So it goes and checks whether I have what I have deployed on my cloud so far. So you see now back to the drift thing that I was telling you, people manually going to deploy things. So now it goes and checks on this particular file. So if this file is like a register, an inventory, it checks, okay, he has an S3, he has IAM, he has a network, he has etc, etc, etc. So now, based on that, it looks at what I have changed on my code, and then it's now, because it has not seen an EC2 instance called web server 1, then it goes ahead and discerns that, okay, this guy wants to create a web server. So he does web server 1 with this particular information, with these tags, and then with so with security group IDs, this will be known after application, and then delete on termination. So you have this this information that you have just added. As you can see, true volume size is 10, volume type is GP3, but I have the ability to add all these other things, and then another instance. So basically that's it. And then it tells me the other things I want created. So it tells me this and this and this and this and this and this and this. So yes, I think that is enough for today. I mean, sorry, that is enough CICD uh, CICD talk for as far as Terraform is concerned. So now let's delve to the security part. So as that is compiling, oh, I went back. So as that is compiling, we go to we go to my security tool of choice for IaC is something called Chekhov. So Chekhov is done by wow, Chekhov is done by a company called Prisma. So they have a policy as code for everybody. So they're able to analyze infrastructure and scan, blah, 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 for Terraform, CloudFormation, Kubernetes, ARM templates, and so on and so forth. So as you can see, this is what they're doing. So what's my implementation for Chekhov is for Terraform. So what I have for on my Chekhov scan is so it installs the requirements and then it runs Chekhov. So I think this is what I want you to see. It's loading. Give it a second. Yeah. So once it runs this Chekhov, um, you're able to see the vulnerabilities that are there. So basically, what I have done, because I don't like coming to look at this, it looks a bit disorganized, if you ask me. So what I do is I'm able to save it, and then I'm able to create a report. So basically that report is what you get to see. Keep pressing that button like over and over. So that's what you have seen there is just this is now the organized version of it. So yeah, so as you can see, the encrypted issue is not there. So you have to go and do all this one by one, one by one. So so for example, let's say on our load balancer, this is what I don't want to do this because if I do this, I'm going to have a very hard time deleting it. So I'm not going to do that. But this is very good for production environments and for places where you're very serious because if this is deleted, then you have to set up a load balancer again. So I am not going to do that, but it's just a line of code. So so the other one that I have will be yes, Aaron.
Yes, I have a question about
Mhm.
is this activities happening on GitHub or GitHub just offers a platform for to do these activities?
It offers a platform to do these activities, and everything is happening on GitHub. So there's nothing
Okay.
happening, all these things, nothing is happening on my machine. So yeah, so I'm able to enable logging for my load balancer. That requires me to set up an S3 bucket, which will take us more time than what we have allocated. Ensure that an IAM role is attached to an EC2 instance. I will not do this because for reasons best known to me, to myself, and then ensure public facing application load balancer is protected by WAF. So this is also good, but for me as a hobbyist, it doesn't make so much sense right now, but these are things that you need to look at and consider. Ensure the default security group. I think we have gone through this. So if I'm happy and satisfied with what I have done, when I merge this, so huh, let's hope it works because it will be very embarrassing if it does not work. These are those things that I have not prepared for. It's something I was doing and I thought, okay, fine, let's do this. Yeah, so so I had something on DigitalOcean some time back. Oh, it's likely to work. So you may ask how exactly this. Yeah, so if you go to my AWS configuration, you will be able to see that all these things have been created. So I have not touched AWS during this whole session, but oh, it has not worked. Uh, because at least two different okay. So so I have to go and create another subnet and another availability zone. So that's for reliability. So I need to go fix that. But I hope you understand the gist of it. So basically, you remember when we were talking about hard-coded keys and authentication credentials. So what happens is what happens for this to go to my AWS, I need a set of credentials that authorizes this. So there are two ways of doing it. There's the way that ChatGPT recommends, where you create a user and you do a secret key and an access key, and then you store that access key. So you can store that access key as a secret on your GitHub workflow. So you're able to pick the secrets on your pipeline is able to pick the secrets and authenticate to AWS, and it's able to do whatever it is that needs to be done. So yeah, so that is how it goes. It checks whether what I have in AWS is correct. And then the other one is using 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 OIDC. So I think I have written about that on a certain blog that I maintain. So to avoid I'm seeing we don't have so much time. Uh, Let me put the link for that particular blog here. It was one of those really mind-blowing things on that I found out about, and I had to write about it. So yes, so I will I will put it on the chart so that you're able to get into details and refer to it much later, which is actually what I am using. So I do not really have keys really. I do not have keys, but you can have your keys set up and so on and so forth. Oh, chat is not available. I'll share it with Hope and then she'll share it with you guys. Yeah. So basically
The
that's it.
Q&A, Kiru.
Q&A. Yeah, Q&A. Okay.
Yeah, even as you share
Okay.
with me, for those
Uh-huh.
on the call, the Q&A is working.
Okay. Perfect. So I think that's basically it. Syntax error, Thomas Adika. When was this? Oh, sorry. Okay. Oh, sorry. I'm not a really huge Teams user, so okay. So it's on the Q&A. So that's it. That's my presentation for today. Are there any questions? Yes, Stephen. Stephen, if you're speaking, you're on mute. Or are you guys
Yeah,
able to hear Stephen? Oh, okay.
able to. Yeah, okay. Yeah, thank you for this, Kiro. It was a wonderful session. But my simple question is, I've seen you provisioning only for AWS, like only for that. So what my question is, AWS provides cloud formation like for IaC. So why would I use Terraform and leave at cloud formation?
Kiru, you're muted.
Okay. That's a very good question. I will answer. I will break down your question into two. So you have CloudFormation. CloudFormation is also a very good solution. I think at the end of the day, it boils down to preference. So the reason why I chose Terraform was because it's mainstream and basically that's what people use. So employability up, and then the other one was why whether it's just AWS alone. So what I have shared on my screen is what they call the Terraform registry. So you have a lot of providers and libraries that you can interact with at based on this. So you have AWS, you have Azure, you have Google Cloud, you have Kubernetes, Alibaba Cloud, OCI, uh, HashiCorp Console Service, Helm, IBM Cloud, Nomad, and so on and so forth. You have partner providers, Akamai. Uh, you can see it's 155,705 providers only. We have not touched modules. You have Checkpoint, you have Citrix, you have Active Directory, you have F5, you have uh, Imperva, you have Cloudflare, you have etc, etc, etc. For me, I am just using my my environment right now is basically I'm using AWS for the moment, at the moment. But I don't know if you're keen enough, you might have seen a DigitalOcean folder. So I had some things running on DigitalOcean. So basically my DigitalOcean configurations are going to be here. If I have an Azure, uh, if I have things running on Azure, I'm going to create another folder, name it Azure, and I'm going to have everything Azure there. If I have Cloudflare for DNS, I'm going to have Cloudflare. If I have Imperva, I'm going to have Imperva for WAF, and so on and so forth. So the list goes on and on and on. You have 5,705 things to do with Terraform right now. I hope I have answered your question.
Yes,
Okay,
you have it. Yes.
Don, yeah. Yes, Don. I'd seen Don raise a hand, but you can go to Davis.
Okay, hope I'm audible enough, Kiru.
Yeah.
Okay, thanks for the presentation. I think you've done a very good job on that presentation. So now, I just have a few questions. One of it is around management of, let's say, something like the secrets, like AWS secret keys for authentication. You said that you need to store them, like if you're using GitHub, basically you store them under those environment variables in GitHub. But how often do you now rotate these secrets? Because at the end of the day, you don't know when they have leaked, because we have things like supply chain attacks. And how do you monitor the activity on these maybe authentication and activity some of these secrets perform on the environment itself? Yeah, those are my two
Uh,
questions.
so basically, uh, maintaining, rotating, just basically key management practices. And what was your other question? Rotating
My other question was,
secrets and uh-huh.
and also how do you monitor now the activity that the keys are performing on, let's say, like
Uh,
AWS or GCP? Because
okay.
basically you don't know if an attacker has taken over them. It's like those, yeah.
Good question. Good questions. So, I have a very controversial answer because managing uh managing keys was actually a problem I had. That's why I had to go look for something else that was sustainable that worked for me. So, huh. So managing your keys on GitHub Secrets is a bit difficult because you do not have you have issues rotating these keys, so you're not really well, because it's me, because it's me managing my setup. It's very straightforward. I have I'm able to see what's it called. I'm able to, I know, I'd like to believe that I'm the only one who has seen those keys and I'm the only one who has access to those keys. But these keys at some point were on on my computer clipboard when I was copy pasting, right? So I do not know whether those keys have leaked or they have not leaked. So why not use keys? Why avoid using keys whenever you can? So you have to manually rotate them, unfortunately, for if you want a scenario like this one. If you're using yeah, if you have a scenario like mine, you have to manually rotate them. So otherwise you can take the very controversial route and not use keys at all. So different cloud service providers are coming up with different providers are coming up with very innovative ways for handling machine-to-machine authentication. So you can look into one of the, so for on that link I have put on my on the Q&A, you can read about how to the alternative of how I do mine for AWS. So basically I leverage on OpenID OpenID Connect to authenticate to authenticate to AWS. So that way I am I am keyless, I am secretless as far as my Terraform and AWS configuration is concerned. Yeah, so now I only have I have to play a game of managing my roles and privileges. Yeah. So basically that's it. Monitoring keys. If you're monitoring keys, you can leverage the cloud native solutions that are there. So you can have the AWS logging solution. If it's GCP, you can have the GCP logging solution, and so on and so forth. Yeah, you can set up your own logs were able to see this key was used by this from this IP address and so on and so forth. Yeah. And then you can have a whitelist set up. Yeah, a whitelist to have only accept. So like now for my OADC setup, I have a whitelist to accept only connections coming from this repo and from particular branches. So that way, unless it's not this repo, unless you found a way to deploy to get my GitHub credentials and use my repository and make changes, then I am screwed. But otherwise, I am okay. Yeah, I hope I have answered your question.
Yeah, I think you have, though around using cloud native solutions, some of them are not optimal because I think a while back I encountered this issue whereby I was storing some of the secrets on, what do you call it, Firebase. I think Firebase have a way to store secrets, but I think the secrets were leaked somewhere else, and we're encountering several attacks consistently. I tried to rotate them and everything, but there was no proper way of curbing that. So we just opted for other solution in that case. So some of the native solution basically they don't provide that optimal way of monitoring the activity of these secrets. Yeah.
Okay. I think that's something we can do more research on, and I'm also, yeah, I don't want to provide opinions that might land me in trouble today or tomorrow, but you can always reach out to me and we can have that conversation on the side.
Okay, perfect.
Any other question? Dawn is, or was it a false positive? Okay. Mhm.
Any other questions before I bring the session to a close? Okay. So, Kiiru, do you have any last remarks?
Oh, yes. Career prospects. I forgot about that for a moment. So this is going to make you employable in in tracks where you're looking to get into cloud security, DevOps, DevSecOps, and application security. And also what's it called? You just have a career path in cloud generally. Yes. This is going to get you there where you can learn about all these things. Charts, that's read documentations, Medium blogs. I don't think I haven't used Try Hack Me's and Hack the Boxes in a while, so I don't know if they have content on the same. Yeah, so basically that's it. Oh, and X. Yeah. Apart from the uh contemporary banter that you see on X, follow some people, learn learn one or two interesting things. Yeah, that's it. Thank you very much, Hope. Thank you for the opportunity. Thank you very much for lending an ear to me for 1 hour and so close to 1 hour, and I hope this is very beneficial for you and you have been able to learn something, and I hope you will be able to better secure to implement IaC first and then implement it securely. Thank you.
Thank you. Thank you so much, Kiiru. Thank you. As always, the sessions are very practical and quite interactive. Thank you so much. Thank you also everyone for joining the call and engaging as much as you can. So as usual, I do advise that afterwards, take time to just watch the video in your own time, pause and internalize different areas. Yeah. And let this not just end here, but let it be a learning opportunity to each one of us. So, yes, Brian, your hand is up.
Yeah, I wanted to know where can I access these recordings for the job hunting and mentorship sessions?
So the recordings are there on YouTube, the Cyber Shuja page.
Okay, thank you.
Welcome. So thank you so much, everyone. Have a lovely night and see you next Thursday. Bye.
Bye.